I would like to ask our first speaker, Valentine Martin, in order to share her screen. And she will speak to us about the metal ring idols, a material approach to metalworking during the Aegean Neolithic. So, please, Valentine, please.
Can you hear me?
Yes, you couldn't speak very slightly louder?
Yes.
Or perhaps come a little bit closer to your computer. You're just a very little bit quiet.
Is it working?
Ah, now that is a lot better, yes.
Okay. Okay, so can you see my PowerPoint?
Yes, we can see your PowerPoint fine.
Okay, perfect.
And, we can also hear you fine. So please go ahead.
Okay, so good afternoon, everyone from Greece. To begin, I would like to thank the organizers of this conference for accepting my communication. So I will present you some results of my master research of last year, which is also part of my PhD research I'm doing in Paris under the supervision of Professor Ara Prokopiou, Dr. Zoe Tsirzoni, and Dr. Sven Hansen. So I will present you the metal ring idols and material approach of metalworking during the Aegean Neolithic. We will see how the study of these objects through analysis and experimental archaeology can be used to understand metalworking techniques at this period. So first, a few words about our chronocultural context. We are in Greece, in the Aegean world, and the objects I study came from both northern and southern Greece, but also from Aegean islands. And the links with of these populations are very strong with the neighbored regions, such as Bulgaria in the north, and you have Anatolia in the east. The Aegean Neolithic begins in the 7th millennium before Christ and ends around the end of the 4th millennium. The period of our interest today is the end of the Neolithic, so right here, between the end of the 6th and the 4th millennium, because new techniques are introduced, like the metallurgy of copper, gold, and silver. And a lot of prestige goods are produced, such as the so-called ring idols. These are ornaments made like a disc or a ring that might be convex, and the central opening of the ring is more or less large. And the top of the disc, we have sort of an extension perforated once or twice, sometimes more, and that extension is, let us think about a suspension ornament. We call them also idols because a lot of researchers interpreted these ornaments as a very schematized and abstract form of female body, possibly a pregnant one. The Aegean populations used very different materials to make ring idols, such as stone, bone, shell, clay, copper, gold, and silver. And moreover, the ring idols are not just specific to Greece. We found them all around the southeastern Europe, in the Balkans, and a little bit more later in Anatolia. The metal ring idols that we found in Greece came mostly from domestic contexts, but this might come from venereal contexts. Some of them have been found in hoards, but the problem is that we didn't find any tools, structures, or waste near to them, and so it is very difficult to understand how these were manufactured. Even if the production seems to be local, we didn't associate ring idols with any metalworking workshops. So why I decided to use the example of the ring idols to approach the emergence of metalworking in the Aegean Neolithic, because these are one of the first objects made with metal during this period, and it is some sort of standardized production. We have always the extension, the opening in the middle, and the flat ring. It can be used to make a repository of techniques used in the first metalworking in processes in Greece. With previous works of researchers about ring idols or about metalworking during Neolithic and Bronze Age in Europe, I can propose some techniques and manufacture processes used by Neolithic populations to make ring idols. So here is the technostylistic tree that resumes all these processes, and I use this to show the differences of shapes depending on the techniques used. So first we have the extraction of metal from the ore. It is about primary metallurgy, so my interest is more in the following steps. And here we have two directions. Either the craftsman prepares a very thin sheet of metal by hammering for a long time and gradually so as not to crack it, or the metal is transformed into an ingot, which will be ready to be worked by the craftsman. In the case of the metal sheet, it is cut into the desired shape, here in the shape of a ring idol, and the tools may have been copper or flint chisels used as intermediate tool in direct percussion. With an ingot, we have two possibilities, the hammering or the casting. Cold and hot hammering are practiced with stone hammers and interrupted by phases of annealing. It is also possible that some ring idols have been hammered on a concave support, and casting could have been done in open molds made of stoneware or of fire clay. Then it seems that the ring idols have been perforated with copper or stone drills and polished with abrasive stones, and maybe other abrasive things like sand or laser. So we propose all these operations and we tested them by experimental archaeology and if they be possible with Neolithic tools and techniques. Our purpose was to reproduce the manufacturing techniques and this from the shaping process to the finishes. We didn't work on the raw material acquisition and extraction, nor on smelting processes that make parts of primary metallurgy. We also didn't use a Neolithic furnace to melt the copper, and we used copper and not gold or silver because that was a more affordable material. So I worked with a blacksmith, cutler, and a ceramist, and our experiment was financially supported by the APERA. This is an association, student association, which cares of experimental archaeology in Paris. For our experimental protocol, we initially decided to experiment with three major technical processes. First, the hammering, then the casting, and the perforation. And we didn't have so much information about this sort of very ancient metalworking. So our idea was to, as the experiment progresses, to identify which technical action or which gesture will be more appropriate to obtain a result such as seen on archaeological objects. So this experiment should be really considered as a first test. To obtain copper like the one used by Neolithic populations, we made sort of copper pebbles after remelting industrial copper, but pure copper. So these pebbles were our raw materials to make samples and to make ring idols. As tools, we had 9 different categories of stone and copper tools, but mostly stone tools, because it is known that people at this period started working metal with stone tools. Most of our tools were rudimentary, namely basic stones, rocks, or pebbles, without reshaping. In fact, their form was chosen according to our technical needs. So in archaeological context, this type of tool is recognizable by its exogenous origin and by traces, because traces caused of because of its use. So we had 5 groups of stone tools, such as rudimentary stone hammers, endless hammers, abrasive stones used as polishers, and drills, and also supports, pebble supports. Then we had crucibles and molds made of mostly fire clay. And we had 2 types of copper tools, chisels and drills, made according to archaeological models that we found in Alepotripa, Pescacia, Paradisos, or in Zast cave. So first, the hammering. This shaping process is based mainly on an alternation of hammering and annealing. So the metal is regularly heated between 2 tool actions in order to make the copper more malleable and to prevent it from cracking. So we use the handled hammer when the metal was hot, and the big stone hammer without handle when it is just warm or cold. 50 minutes after doing that, we obtain metal plates as thin as some ring idols, so about 3 to 4 millimeters. Then we tested another sort of hammering, the planing. It is employed for hammering finishes. We used to make it in direct percussion with a flat hammerstone and an intermediate tool, such as a piece of wood or stone. We also experimented hammering and planing on another support that a modern anvil. We used a pebble with a rounded surface, and we hammered metal on it to obtain the same convex forms that we can observe sometimes on ring idols. It took about 10 to 15 minutes to get the curve. Then, to obtain the final form of ring idols, we drilled the central perforation as a central opening, and we created the final contours of the ring by very light hammering, using the horn of a modern anvil to make the roundings. For the casting, we used 2 techniques to make ring idols. So the classic one with the open molds. But first, we tested to use a sort of a pre-shaped crucibles. Our idea was to directly cast the form of a ring by depositing a little round pebble in the middle of our crucible. And we placed some pieces of copper around the pebble and melted it. It really worked because we obtained a copper ring quite thick, which has been reworked by regular hammering, in direct percussion and with some annealing. So finishes were made by indirect percussion with light planing tool and by scraping with an abrasive stone. Then, in order to regularize the central opening, we rubbed the abrasive stone in rotation from left to the right. And finally, we have left certain thickness of copper on one side of the ring, and this side was hot hammered to obtain the upper extension of the ring idol. Then we decided to experiment classic casting with two open monovalve molds made of sandstone, but it didn't produce the desired results. So the copper took a long time to melt, and then we couldn't unmold it. As we can see on the picture, here the metal has completely infiltrated the sandstone. It would have been necessary maybe to add an agent facilitating the unmolding, and this before the melting of copper. But it is also simply possible that the composition of the mold and its degreaser was not adapted to this type of use. But even if we didn't succeed, it is known that casting has been used to make ring idols at the end of the Neolithic, because on the one hand, molds have been discovered, and on the other end, because casting has left specific traces on the finished objects that could be observed sometimes. Finally, the perforation. So first we made it with flange drills on the sample, and by unilateral drilling, it took 2 hours and a half to perforate the copper. And the perforation is, as we can see on the picture, very clear. And then we employed the same technique on a finished ring, and it took a little bit more time, so 3 hours and a half. But again, we obtained such a well-made perforation. And on the other end, the experiment of perforation with a copper drill has been much less successful. After several attempts with indirect perforation, it didn't perforate the copper, but we think that if the same action had been performed on a much thinner metal sheet, for example, a real gold leaf, it might have worked. So we will try it again in the future. So finally, we found some time to experiment polishing a little bit. We polished the ring idols and the copper samples with abrasive stones. Our action was simply one way back and forth movement. We also added some water as lubricant. This made it possible to evacuate the copper residues that we are hindering the smooth running of the polishing process. And the polishing made the surface shiny and smooth, but it didn't remove all traces of manufacturing. If this idea had been our goal, to remove all traces, we could have used stones of increasing Crete size and other abrasives. So as a result of our experiment, I would like to correct some aspects of the technostylistic tree that I presented previously. First, I didn't talk about the cuting of metal sheet because we tested it and it was very difficult. So as for the perforation with a copper drill, I think this kind of technique can be more successful on a real thin metal sheet. So this situation makes us think about really trying to create metal leaves very thin, like those we found during the final Neolithic, just here, possibly in gold and silver for future experiments. So all the operations, all the technical operations proposed in the techno-stylistic tree are not so easy to make. It requires a very good knowledge of the material and obvious craft skills. The chain operatoire is not linear, and I think we could talk about several chains opératoires. We have the cold hammering, the hot hammering, the planning, the cutting, the casting. and the finishes. And all these techniques can be used separately, but also in the same process. So, for example, we can find some objects probably made by cold hammering, but also by hot hammering without planning, but with a very extensive hammering in order to obtain the curved form of the ring idol. So, several chains opératoires, and these chains opératoires can overlap with each other. So as a very final conclusion, I think it is important to say that this first metalworking is not based on simple techniques and gestures. On the contrary, there may have been a real cross-specialization, which should be first understood by more studying this technique and by taking, for example, other objects that ring idols. So thank you very much for your attention.
Thank you very much, Valentine, for a really great opening to this conference. Absolutely fascinating insights into early metallurgy. And now if I could ask you to stop sharing your screen now so we can move on. Thank you very much. We can move on to the next paper. Bang on time as well, by the way, thank you. And our next paper is Repair, Reuse, Recycling, a stake from Ayia Triada on Crete. And this is going to be given by Marianna Figuera. I hope I pronounced that correctly. I do have a habit of mangling other people's names, but please, if you could share your screen.
Yes.
Okay.
Okay.
That looks great. Yes. We can hear you and we can see your presentation.
Perfect.
So please go ahead.
Perfect, thank you. Good morning to everyone. And first, I would like to thank the conference organizing committee for this opportunity to present my work, and that started after my PhD project and is still in progress. It is part of a wider project focuses on the metal finds found on the Cretan site of Phaistos and Ayia, and their role played in the metal production and circulation during the palatial periods. The project is funded by the University of Catania, the Institute of Aegean Prehistory, and the Mediterranean Archaeological Trust. Today, I'm going to illustrate to you some aspects related to the manufacturing activity of the bronze in the site of Ayia, to defining the role that it would have played in this site. Ayia is one of the most important Minoan sites in Crete, with a very long history, started in the pre- and proto-palatial period and reached its main development in the Neopalatial phase and continuing its history across the centuries. The site has been investigated by the Italian Archaeological Mission since the early years of the last century, thanks to the excavation by Albert, Stefani, Banti, and the last Vincenzo La Rosa. During the Neopalatial phase, in late Minoan 1B, the site reached its final outline when it was organized around the so-called villa, here in light blue. The main areas are the so-called village to the northeast, here in orange, and the northeast sector, not so far from the necropolis. Some of the Neopalatial context was subject to sudden abandonment in late Minoan 1B, as the signs of fire and the quantity of valuable finds found in the rooms of the villa and the settlements seem to suggest. In particular, the metal finds stand out for the quantitative richness that is an unicum. Just think that the metal found in Ayia Triada are equivalent to about 60% of those found during the Neopalatial period in the entire central region of the island. If Ayia Triada is a good case for study the distribution and the use of metals, on the other hand, the possibility of defining the role played by the site in the metallurgical industry is always difficult due to the rather small presence of archaeological evidence to identify any areas in charge of this activity. This absence would also seem to be reflected in the almost total lack of reference to the metallurgical production, as well as to raw materials or semi-finished metals in the linear A tablets coming from the site. From the re-examination of the metal finds and their contextual and functional analysis, some aspects related to the bronze manufacturing activity emerged that allow us to begin to define the role that this would have played in Ayia Triada. Today, I want to leave out the aspects related to the presence of the 19 oxide ingots found in the room number 7 of the villa, and the question related to the presence or not of a metallurgical industry in Ayia Triada, because the project is still in progress, as well as the leads analysis performed by the Fourth Institute in Heraklion about the elemental composition of the finds. So today I want to focus on some processing phase, such as repair, reuse, and recycling, starting from the analysis of a single tool, a stake, that is a sort of anvil. This is the stake, and these tools summarize a double factor of interest, being first an uncommon object made in bronze and used as a tool in the metal basis manufacturing. The stake is stored in the Heraklion Museum and is currently exposed in the 4th room. It is a bronze object, 50.5 centimeter long, with a S-shaped and quadrangular section of variable thickness between 2.6 and 2.9 centimeter. One end is hemispherical and the other is quadrangular and flat. In the middle of its length, there is a flat element. The total weight of this object is 3 kilos. Through the analysis of bibliographic sources, it has been possible to reconstruct its context. The first to refer to this artifact was Mosso in 1907. He called it anvil and supported the typological interpretation by an ethnographic comparison as an example of technological continuity between Cretan artisans of the Bronze Age and those contemporary to him. After a silence of over 50 years, the tool was already mentioned as a lever, as a anvil in 1960, used to produce bronze bases. And for the first time, it was specified that the finds was stored in the Heraklion Museum. A different interpretation is in Sakellaraki's 1978, where it is mentioned as a lever exhibited in the Old Museum of Heraklion that has the same inventory number of our stake. In 1986, Ant published a short paper dedicated to Minoan bronze tools used for forging metal bases, one from Ayia Triada and the second from Catosacros. The same two examples are also in Italy in 1993 between tools used for shaping. And finally, Clark in 2013, in the book dedicated to the production of non-metal vases, adds a third stake from Sambas in Pediada region. So the first comparison for our stake is therefore the tool from the west wing of Zatos Palace, dated in late Minoan 1B as our stake. It is stored also in the Heracleon Museum and is as a slight carved shape and two work surface. Originally it must have been longer and now it is broken off. The second one is from Sambas in Pediada region. It is also stored in the Heracleon Museum, but its dating is unknown. It is classified as hammer or a T-shaped stake with a circular handle and two ends, one longer with an oval section and carved surface, and the other with an octagonal circular section and a flat surface. But the best comparison to understand the use of this tool is in Egypt, and specifically in the wall paintings of the tomb of Rekhmire, where there is a representation of activities carried out by potters, carpenters, metal workers, and so on. The latter appear to be involved in different moments of metallurgical production, as smelting and casting, including the shaping and finishing phases of large metal vases by hammering and polishing. The tools they use, very similar to our stake, are placed diagonally, propped up with a frame, probably made of wood, and inserted inside the containers to act as a kickback to the hammer when beating the external walls, or as a pivot for rotation of the vases to be polished. In all the bibliographic sources, the attention to this find is always directed to its functional interpretation, but its discovery context is never investigated. Unfortunately, there is no trace of this artifact in the preliminary reports by the first excavators, Albert and Beni, neither in the wall edition about the excavation of the villa by Banti, Albert and Stefani in 1977. And the total absence of reference to this tool is also in the most recent publication dedicated to Ayia Triada. So for the recontextualization of this tool has been necessary to restart from the notebooks of the first excavators. In 1903, almost the whole villa was brought to light, and the excavation began from the northwest corner of the hill. And in the notebook number 3, Beni notes the discovery of a bronze bar, which was similar in shape to a tripod foot, or to a particular type of stool called difros, which are therefore slightly carved. So all these characteristics have made possible to recognize without any doubt our stake in this description, because it is an object with a unique morphological and typological characteristics, and was rarity in Aegean context, as already been explained. Now I want to propose some observation about the relationship between its context of discovery and the functional aspects of some rooms of the villa in relation to metallurgical activities as repair, reuse, and recycling. This area in green is called Northwest Quarter, and is characterized by the presence of rooms richly decorated and finished with floor and wall slabs of alabaster as polytira, courtyard, and halls, and by a group of service rooms in yellow, used as warehouses or storage rooms and working areas, communicating each other and accessible only from the inside. The presence of an upper floor is indicated by the stair preserved. In the northwest corner of the villa, there is the porch number 11. Here, only 2 columns and 1 pillar remain, while the other corner of the porch has been lost due to the collapse of the hill. Here there were found many different finds from different heights, some from the upper floor as cretules and 5 linear A tablets and many fragments of painted plaster, and other from the floor level as a large number of stone vases, some decorated including the so-called ritorno dei lottatori, few pottery, and a large bronze bar corresponding to our stake, closer to the floor of the porch. This area seems to have been used for many functions, which involved closed spaces, the upper floor, semi-open spaces, the porch, and external spaces, the courtyard. The porch number 11 was connected to 2 sectors consisting of rooms number 3, 12 and 4 on one side, and number 13 and 14 on the other. The sacral nature of this wall complex has been stressed several times with reference of room 14 that is frescoed, and in connection with ritual and ceremonial activities linked to the use of the polytera, opening and closing systems. This aspect is flanked by the administrative character, which is reflected in the presence of an archive on the upper floor of the porch number 11. So how to interpret the presence of the stake? It seems to suggest the carrying out of activities of an artisanal nature, which had to take place outside and which do not contrast with the other destination. As we know, the metallurgical production was characterized by a segmentation. In fact, each phase could be carried out in different locations and often far from each other. In addition to real workshops, there could be simple working or activity areas without specific connotation. Often different forms of works share the same production spaces. It is also necessary to distinguish between the metallurgical activities involved in primary production, as melting, alloying, casting, which have archaeological indicators as raw materials, processing waste, tools, and installations, and metallurgical activities involved in secondary production that are not comparable in terms of archaeological indicators. The finishing technique, in fact, could be cold or hot hammering to shape the object, to repair, or to recycling. This type of processing involved the use of metal or stone hammers and could include the use of portable ovens, crucibles, or simple ceramic vessels, and the use of coal as the most common fuel. The characteristics of this context suggest an interpretation of the open spaces as also intended for secondary activities of the metallurgical production cycle. We have no information about a large part of the porch due to the collapse of the hill, so we can hypothesize that the bronze vases were made elsewhere and the activities carried out here were linked to repairs the metal containers that were used and stored nearby. This interpretation must consider 4 information from the notebooks. The first one is that together with coals, there were 3 pieces of gypsum plates in a vertical position on the ground. The description is not significant in itself. However, in this case, it could refer to a sort of installation. But if these were linked to the presence of our stake for hot hammering or for other type of activities, it's not possible to establish actually. The presence of lithic and pottery containers, which characteristic as many small holes, the discovery of a fragment of amorphous bronze object without any other information, and finally the presence of our stake, that is an instrument used for polishing and or beating metal vases. In favor of this hypothesis, there are, first of all, the greatest concentration of metal vases in the western wing of the villa, in comparison to the other parts, the other quarters of the villa. All the 6 bronze hammers mentioned in the notebooks come from the western wing of the villa. 2 identified in the Heracleon Museum are from the room number 40, and due to their size and their weight, seem to have been used for forging large objects or to break the ingots. 8 bronze handles of different sizes found in the warehouses of the Heracleon Museum, without any mention to their context of discovery, even if in the notebooks the discovery of sporadic bronze handles from the villa is mentioned. In any case, they are also proof of repair or recycling activities. So in conclusion, the presence of our stake together with other many bronze tools in the northwest quarter of the villa shows that some of these rooms were connected to production and transformation activities. In particular, the room number 45, here in yellow, is interesting because it's characterized by the presence of 3 cuneiform installations in clay covered with lime, and a large rectangular slab, perhaps a work table. It is possible to hypothesize, as already proposed by Pietro Militello, that this space was also intended as a working area for the repair of metal objects. In fact, a spearhead broken into 3 parts, 2 small chisels and 2 ribbon foil were found here. These rooms connected to production and transformation activities were in close connection with the official rooms. However, in the porch number 11, in red here, the porch number 11 was not a space dedicated only to production or transformation activities, but in this open space, it is possible to imagine the development of activities linked to the working of bronze vases, as finishing, repair, or recycling, without invasive installation, in contrast to the more elegant rooms of the northwest quarter. So once again, the co-presence of domestic, storage, and artisan functions, perhaps temporary or periodic, in the same spaces of the villa has been confirmed, as well as the presence of some kinds of metallurgical activities in Ayia Triada. And thanks for your attention.
Well, thank you very much, Marianna. That was very interesting to us metallurgists in particular, but hopefully everybody really got something from your presentation there. If I could ask you to stop sharing your screen now, please.
Yes.
So that we can move on immediately to our 3rd presenter of this session, who is Polina Kapsali. And she's going to be speaking to us about exploring the social dimensions of Middle Bronze Age pottery through firing technology. So, Polina, if you could please share your screen. Okay, that's looking great. I can't hear you.
Okay, yeah. Hello, everybody. Thank you, Steph, and many thanks to all the organizers of the conference. The topic I will present today stems from my master's dissertation, which I completed at the University of Athens in 2018. At the time, I was studying 2 late Middle Bronze Age pottery kilns from Plus in Marathon as part of the university's excavations at the site. This work prompted me to start thinking more systematically about the element of firing in the making of pots and how this particular activity can inform us about the techniques people used and the pots they produced. Kilns, in their own right, cannot provide us with this kind of information. For this reason, one has to look at the final products themselves, the pots, in order to reconstruct what was involved in their making and to approach the social dimensions of pots. It is from this second part of my research on firing techniques of ancient ceramics that my presentation stems today. I will start by presenting some of the social aspects of firing technology. Firing transforms permanently the properties of pots. It can transform a soft and malleable mass of clay into a container of a completely different texture that can receive contents and resist wear. Alongside surface treatment, firing determines the visual characteristics of pots. As these visual characteristics are affected and at the same time shape people's aesthetics, firing techniques can contribute to the study of shared aesthetic codes in smaller and wider regions. In affecting the visual performance of pots, firing transforms the color of surfaces from that they originally have because of the raw materials to something quite or completely different. Although surface color is always recorded in pottery studies, it is often not considered as a social aspect. Yet color has a powerful impact on the viewer, playing an important role in social life, that is, in the ways people engage with the material world and interact with other people. For example, color facilitates the establishment of connections between otherwise unrelated things, helping people shape and perceive particular social and emotional situations. In addition, firing techniques can offer important insights in the ways technical knowledge is transmitted, complementing the study of other technical processes belonging in a similar operational sequence, such as fashioning or surface treatment. In terms of transmission, firing techniques seem to position somewhere between fashioning and surface treatment. Firing leaves a direct visual and observable effect on the final product, and this optical effect is prone to imitation. The same happens with surface treatment techniques, for example, with painted decoration. Yet firing techniques cannot be easily read on the final product and by extension reproduced by imitating the visual properties of final products. They should therefore be taught and learned in order to be reproduced, an aspect that brings them closer to fashioning techniques that also require what is called apprenticeship relations. To sum up, firing techniques are on the one hand connected to local or regional networks of interaction and knowledge transmission, and on the other hand with widespread aesthetic codes. It is on these two elements of firing techniques that this presentation aims to make a contribution. In the last 15 years, the general effort to explore the Middle Bronze Age communities of the Greek mainland led to an increasing interest in studying the technical characteristics of Middle Helladic pottery. So far, fabric analysis and fashioning techniques have received most attention. Firing techniques, and especially their social dimensions, have gone largely undiscussed. To illustrate the importance of studying these techniques, I will focus on the monochrome burnished pottery, or what has been for a long time known as minion ware, one of the most, if not the most, characteristic pottery categories of the Middle Bronze Age on the Greek mainland. This archaeologically defined category of pots is characterized by monochrome vessels with well-burnished surfaces made of fine to semi-coarse pastes. The pots have mostly gray, brown, and black surfaces. Light color surfaces, such as buff and reddish, also occur, predominantly at the beginning and at the end of the Middle Bronze Age period. Given the brevity of this presentation, I will focus mainly on gray and dark colored pots. This broad category involves predominantly wide-mouthed tableware pots, probably used for the consumption of food, beverages, as well as for serving. A wide variety of cups and bowls is attested, some of which you can see on the slide. My analysis is based on published material, particularly on a comparative study of scientific results, combined with macroscopic observations originating from the examination of Middle Bronze Age pottery. As a starting point, I used the results of the analysis conducted for the Middle Bronze Age pottery from Colonna on Aegean. Concerning the pots that can be included in the monochrome burnished category with grey and dark colored surfaces, 3 different firing treatments can be reconstructed. A firing treatment that involved consistent reducing conditions has been identified. A reducing technique involves the firing of the pot under an atmosphere that prevents the circulation of oxygen in the firing structure. Macroscopically, this treatment corresponds to surfaces of homogeneous grey color, with sections also presenting a consistent grey color. This technique is generally considered difficult to control because the presence of oxygen can help the increase and maintenance of high temperature inside the firing structure, something that is desirable when people fire pots. The blockage of oxygen in reduction can make it more difficult to control these parameters. Besides, the production of consistently reduced pots is, among others, also a matter of post-firing treatment. The circulation of oxygen in the firing structure after the firing process has been successfully completed can transform the color of pots, turning grey or dark surfaces into reddish and lighter colors. Alongside this firing treatment, the examination of a few other grey burnished pots indicated the application of less consistent reducing conditions or of a reducing atmosphere for a shorter duration. Pots appear to have been exposed initially to an oxidizing and subsequently to a reducing atmosphere. The circulation of oxygen in the firing structure is indicated by either the section or both the section and the surface of the pots. The section is heterogeneous with a core, as you can see on the slide, and the color of the surface often presents a slight color variation, mainly in the hues of brown and grey. The last firing treatment that can be identified in dark-colored pots appears to have involved mixed or oxidizing conditions with a final stage of intense reduction. This treatment appears to often relate to higher temperatures, something that is probably associated with a very shiny effect of some surfaces. The surfaces of these pots were also covered with a slip, a treatment that did not appear in the earlier mentioned pots. Macroscopically, this firing treatment corresponds to sections of homogeneous color or to sections with cores, as with number 92 that you can see on the slide. The color of the surface, defined by the properties of the iron-rich slips used, is fired more frequently to a dark grey or black color. Starting from these combined observations that are available for Colonna, I try to explore variations in the firing treatment of grey and dark-colored pottery from the sites of Pevkakia in Thessaly, Elefsis in Attica, and Agios Stephanos in Laconia. I focused on macroscopic observations concerning the colors and the color transitions observed on the surfaces and the sections of the pots. At Pevkakia, grey burnished pottery was produced in large quantities during most of the Middle Bronze Age. As it is evident on this slide, a wide variety of pots used for the consumption of food and drinks and for serving were produced in this category. The observations originating from the macroscopic study of these pots suggest the existence of different firing treatments. On the one hand, there are pots that should have been fired under consistent reducing conditions, indicated by the homogeneous grey color of the surface and the section. The existence of slightly brown and red hues on the surface of pots with homogeneous grey sections possibly indicates the exposure of a few of these pots to oxygen during post-firing or cooling phase. On the other hand, there are also grey burnished pots fired through a treatment that involved reducing conditions of possibly shorter duration combined with oxidizing conditions. This treatment is indicated by the existence of cores in the section. combined also with color transitions on the surfaces. In the course of the Middle Bronze Age, the frequency of consistent reducing firing treatment increases. Turning to LFCs in Attica, a large variety of predominantly tableware forms has grey and dark surfaces in the period under study. Similar firing treatments as those identified at Pefkakia are also observed at LFCs. Most of the dark-colored burnished pots seem to have been fired under consistent reducing conditions and have grey surfaces, while less consistent reducing conditions appear less frequently. By comparison to Pefkakia, however, at LFCs, there is a larger percentage of dark-colored pots that have been fired under mixed or oxidizing conditions with a last stage of intense reduction. These pots have slipped surfaces and present burnishing marks, a group of features that alongside the firing treatment differentiates them from the grey burnished pots that constitute the majority at the site. If we now turn our attention to Stephanos in Laconia, we have quite a different picture. The vast majority of the Middle Bronze Age dark-colored pottery has been fired under mixed or oxidizing conditions with a last stage of intense reduction, while pots fired in reducing conditions are extremely rare. Like at LFCs here too, this firing technique constitutes part of an operational sequence that possibly involves the covering of the pot surface with an iron-rich slip that is fired to a shiny dark color. Interestingly, at Stephanos, the surface treatment techniques also involve a wide repertoire of mostly incised and impressed patterns, as you can see on the slide, something that only rarely occurs in the dark-colored pottery found in the other two areas. So what can we glean from these observations? As it has been observed by Olivier Gosselin, and I quote, "Not all elements of a technical system are structured along the same symbolic or social lines and should not thus display an intrinsic cohesion," end of quote. To put it differently, the transmission of techniques that constitute part of the same operational sequence may be affected by different forms of social interaction. This stresses the need to establish different frameworks of thought to approach the different techniques. How then should the properties and effects of firing techniques discussed at the start of the presentation be understood in relation to the pots studied here? Firing has a direct visual effect. The result of firing is immediately observable and experienced. The color of pots, a visual property determined directly by firing, is affected and at the same time can shape people's aesthetics. And aesthetic principles have the potential to be transmitted beyond the local and even regional level with their area of circulation depending on the mobility of objects. During the Middle Bronze Age of mainland Greece, similar forms of tableware pottery with monochrome grey and dark surfaces were produced and used widely, from as far north as Thessaly to as far south as the southern Peloponnese. These forms appear to bear conspicuous references to metal vessels and probably silver vessels. These references are reflected in the formal characteristics of the pots, involving features that also appear on metal objects, such as strap handles and body carinations. These visual references are, however, also reinforced by surfaces colors. The latter, ranging between grey, grey-brown, and black, could correspond to the colors of a silver surface when it is left unpolished or when it is left to tarnish for a long time. Here, I don't want to suggest that people just created ceramic imitations of products that were of higher economic value or products they did not have access to. Instead, I'm prone to consider other kinds of relations between metal and ceramic artifacts, embedded in the ways people relate and evaluate the properties of objects. For example, in this case, we could consider the potential effect of tarnished metallic surfaces in shaping the aesthetic value of aged or antique objects. What I would like to argue here, however, is that during the Middle Bronze Age, common aesthetic principles shaped through the effect of the properties of metallic surfaces spread across the mainland. And this is related to the introduction of different sorts of firing treatments involving reducing atmospheres across this area. However, despite the general introduction of reduction across this wide region, a clear differentiation in the firing techniques applied for the making of pottery circulating in the areas of Thessaly and in the southern Peloponnese was observed. It is perhaps important to note that the different firing treatments resulted in different color effects. Here I refer to the distinction between the gray surfaces appearing in the central region and the dark gray to black surfaces that were popular in the southern Peloponnese. The difference in color would have been augmented through the differentiation in an additional property of the surface that was also partly determined by the firing technique. I'm referring here to the shiny texture of surfaces in the southern Peloponnese, as opposed to the generally duller surfaces in Thessaly and central Greece. At the same time, the existence of a repertoire of techniques and motifs for decorating the surfaces in the southern Peloponnese sets this pottery apart. Therefore, despite the possible materialization of common general aesthetic principles across the mainland, distinct traditions developed in this wide region. How should we then understand the development of these distinct traditions? Given that objects constitute parts of complex networks of interactions involving people, other objects, and their relations, it is important to consider multiple parameters that can affect the formal characteristics of ceramics. The differences in the visual properties selected within these areas could indicate that these traditions may have operated on distinct individual aesthetic principles. These principles may have been shaped under the effects of potentially different visual properties of the metal vessels circulating in these areas, or under the effects of formal characteristics associated with other pottery traditions that were also popular in these areas. It is worth noting that in the southern Peloponnese, another pottery tradition, what is archaeologically defined as lustrous decorated or minoanizing pottery, was also popular in the same period. Interestingly, this pottery presents common visual properties with the Bernese pottery, that is, shiny dark to black surfaces that also result from the application and firing of iron-rich slips. Concerning the reproduction of techniques and the development of skill, variations in the firing treatment can be observed even for pots circulating at a site level, despite a generally common intended visual effect. For example, although gray surfaces are generally produced at Pefkakia and LFCs, a variation both in the homogeneity and in the hues of the surface and section colors can be observed in the finished products, and this was attributed to variations in the firing treatment. At Pefkakia, from roughly the start of the Middle Bronze Age, there seems to be an association between pots fired under consistently reducing conditions and wheel fashioning. Another parallel association can be observed between pots produced under inconsistent reducing conditions and handmade fashioning techniques. These combinations of techniques could suggest that the various pots were made by potters operating in different socioeconomic contexts. The adoption of the potter's wheel on the one hand, combined with developed skills in reducing firing, could indicate the existence of potter producing at a more intensive mode, beyond the immediate needs of their domestic unit or even of their local community for purposes of exchange. On the other hand, the rejection of the wheel, combined with the existence of different firing treatments, could be related to people producing similar products at a smaller scale, such as to cover the needs of their domestic unit or even of their local community. Certainly, these are preliminary considerations and further work is very much needed on this subject. I would like to end this presentation by summing up the potentials of firing techniques on enhancing our knowledge on ceramic technology and social interactions, their potential to offer additional insights into the social fabric of past communities, as processes enabling human artifact interactions both at the time of production and use of artifacts. In this presentation, I have tried to argue that Firing techniques are directly related to the topic of aesthetics, mainly on the basis of color and color coding. Furthermore, they allow for an exploration of different networks of interactions in which objects may be involved according to their different properties and characteristics. Last but not least, variations in the firing treatment help us identify paths in the transmission of knowledge and differences in skill on the basis of products used at a local level, leading to an exploration of potentially different socioeconomic scales of production. Thank you very much.
And thank you very much, Polina, for that very interesting talk. It's always good to see a well-known subject like ceramics being approached from a completely different way. So if I could ask you now to stop sharing your screen, please. Thank you very much. And we will move on to our fourth and final paper of this session, which seems to have gone exceedingly fast. And this will be given by Flavia Toscano, and she's going to be talking to us about textile production as an indicator of social change, a perspective from Bronze Age to Iron Age at Phaistos. So if you could please share your screen with us now.
Yes. Okay, can you hear me?
I can hear you fine, yeah.
Okay. Okay, and can you see?
That looks perfect, you're good to go.
Okay. Good morning to everyone, and thank you for this opportunity. It's really a pleasure to be here. I'll try to introduce the results of a preliminary analysis that I undertook for my master's dissertation 2 years ago, and it's still in progress. And I take the opportunity to, because I'm grateful to Professor Militello because gave me the possibility to study these materials. I'm not an expert on technique of making textiles, but textile production is deeply embedded in a society like that of Phaistos, and the diversity, scale, and intensity of production is indicative of the level of administration and control exercised by rulers, regional centers, household, or palace itself. So here the structure of my talk, a brief introduction of the site, but especially about the chronology and the span of time examined, with all issues involved, because as we'll see at the end of late Minoan III, according to previously bibliography, was an emblematic period, but actually is important, fundamental to review and to consider every single local reality. One of the focus will be methodology adapted to carry out this pilot study. And then we can see context, distribution of material, textile material, and the final conclusion. I think Phaistos Palace no need presentation or many words. We know that it's located in the south of Messara Plain, and the ancient settlement was set out on 3 hills, and the easternmost hosted the palace. It's important to stress that for this study, as I said, I focus on the end of palatial period, in fact, from the late Minoan 3C, Cretan post-palatial history is characterized by the abandonment of many Bronze Age sites that had flourished in the 2nd millennium, the establishment of many new smaller scale settlements, and the collapse of the palatial system has been attributed to a range of causes, including environmental, internal, and external factors. About chronology, the collapse of the palace has changed the main aspect of economy and social organization, but archaeological records show at Phaistos a continuity in few areas of the palace. Transformation of the social and cultural role of Cretan society during the so-called Dark Age, transitional period, is clear in material culture and, in our case, through the analysis of manufacture, use and consumption of textile-related material. In fact, aspect of Minoan material culture and practice continued through the late Minoan Free Sea, and in some cases beyond. And we can see in the picture at the right the topography of the palace and the close quarters and location that yielded evidences for of later phases, like Calara or the Acropoli Mediana or Ayia Fotini. And in the low part, at the bottom, we see with in pink or in red the later phases of the palace. So the site of Phaistos yielded an extraordinary amount of textile tools from the Neolithic, and it's a big opportunity to investigate textile activity and its impact in economic and social organization. The analysis of object date and context date demonstrate that there is a change in production from final Neolithic to late Minoan. So, for example, from final Neolithic, we have a lack of loom weights, and the same situation from early Minoan, with a number of with a few number of spindle work and no finds of loom weights. In the middle Minoan, loom weights come from the palace area, and from late Minoan, they are from a household area. So this suggests a change in the organization of the production. And we have many few evidences from the later phases. About the methodology, I tried to investigate the textile material found in late Minoan Free Sea archaic archaeological context to identify elements of continuity or innovation. These materials come from excavation between 1950 and 1966 by archaeological mission by the Levy, and all finds are recorded on the base of CTR database, Central Textile Research of Copenhagen, and it has been important to update database, including material from sporadic context as well as post-palatial context. Unfortunately, some of tools had an uncertain context date because they are from contexts that have an overlapping date. I use published and unpublished material as well bibliography to get every information that I need. And the most important sources are notebooks written during excavation by scholars, archaeologists, and so on, but also label that we can find inside the box, the container where we save all archaeological material. Unfortunately, the problem is that we haven't stratigraphical units. So I start a work of revision to reconstruct the original context of these finds. But as I said, this work is today still a work in progress. In general, we can distinguish four main areas for post-palatial deposit or building. The court 70, the area of Rampe, the area of court the first, and the Acropoli, close to the palace. Despite the center of palace seemed to be abandoned from late Minoan III, the west side part was still in use till at least the 7th century BC. Is impressive, I think, that almost all textile related material come from these three areas with few exceptions. In this map of distribution, we can see the collection of finds from different contexts of the palace. An interesting concentration of finds is in primary context that it has been possible to confirm. Which are these contexts? Primary contexts that I confirm are building are free, room AA, so and geometric ramp, geometric road. Plans, drawing, and notebooks allowed to reconstruct the original position of these finds from its so-called geometric quarter. We can date the geometric quarter from 9th century BC to 7th century BC, and according to Cucuzza, probably they were part of a bigger building used to domestic function. And the ramp instead connected this part of quarter with the palace. You can read also some notes that today are visible in the container that I found in the Stratigraphical Museum at Phaistos that permit me to reconstruct context. For example, notes like below paved slab closer to Figuera and so on. So preliminary analysis include also statistic and metric weight consideration. We can see about spindle whorls there is a suggestive variety in shapes, but for loom weights we can distinguish discodal type with fine clay from discodal type with coarse clay. The 62% of material are spindle whorl. We have a lot of loom weights in our archaeological record, but they aren't indicating reports or notebooks, and for this reason they are considered as sporadic find or typological. So it's impossible to establish the place of this finding. What can we note? What can we say? We have in our archaeological record different shape of spindle whorl, like spherical, cylindric, conical, or also biconical. We can have a look to materials from these primary contexts that it was possible to identify. We have cylindrical types from the building are free. These cylindrical spindle whorls have a fixed lip and they are very, very smooth. And this shape appear in Cretan context starting from 9th century and remain in use at least until the 7th century. Other cylindrical spindle whorl are dated at the end of the late Minoan III, and we can see to the right, and they are obtained by Kilikes. In fact, some of them have painted decoration. Also, we can see in the middle another tool that comes from this building. it's maybe probably it's a weight, but is in raw material, in raw clay and uncooked. A really rare exception for us. Also, we have other loom weights that come from geometric rampa, and they are similar to Hellenistic classes. They were found with the other globular spindlework. With a particular color characteristic of this globular spindlework, a kind of depression close to the hole. Other spherical spindleworks with many variation in type of dough or in manufacture, we can come from building AA, and so we have spindlework from we have spindlework from these rooms with cylindrical shape. Dated to a let me know free context obtained by Kilikes. Then we find spindlework other cylindrical spindleworks come from building R3, dated to 9th century, together with the globular spindlework and cylindrical, dated to 8th, 7th century. At the end, we have this new globular and with a standardization in shape from geometric rampa. So the spinning at Phaistos seems characterized by a phenomenon of tradition and continuity until the geometric period. It changed manufacturing, but the main metric ponderal characteristics remain the same, as we can see in these two tables. So from 12th to 7th century BC, we have different kind of spindleworks, and from 7th to 7th century BC remains just one kind of spindlework, spherical spindlework, from geometric and latest context. So in conclusion, the late Minoan 3C has a typological tradition with the proto-geometric and geometric period, and with a continuity, but the suddenly break starting from the end of 7th century BC with the introduction of this spherical spindlework. At an early stage, they coexist with cylindrical items, but at the end of this phase, spherical ones are characterized by a color close to the hole. And this changing was related to the emerging of the new social system. Again, we have also the lack of loom weights due maybe to close quarter of calera, that we can record a pre-industrial production of loom weights, or to their perishable material, like example from room R3, that was raw and backclayed. This study is still in progress, like I said, but I hope to conclude with many important step conclusion in next month. Thank you.
Well, thank you very much, Flavia, and that was oh, you found some really interesting trends there, and I'm sure given us a lot to talk about in the upcoming discussion session. So if you could stop sharing your screen now, please.
Yes.
And if I could invite the participants, the presenters from that session to turn on their cameras so that people can see who they're speaking to. I thought the best way to organize this was to simply go through each presentation one by one and deal with questions per presenter rather than having a big mix of questions. So just to remind everybody that if you want to ask a question, then you can either raise your hand using the raise your hand function under reactions, or alternatively, you can just put in the chat that you want to ask a question. So, so first of all, if we could have any questions for Valentine Martin. Anybody has any questions, or perhaps I will ask the first one anyway. Just wondering, Valentine, are you able to switch on your video? Ah, there we are. Yeah, we can see you now. Perfect. Okay, so given that nobody has decided to jump in immediately with a question for Valentine, I will do so because I find this particularly interesting, seeing what metallurgy was like right at its dawn. And I was very interested in your experimental approach, and that you were able to demonstrate that the copper drills were unable to pierce the copper sheet, but your flint drills were able to pierce the copper sheet. So could I just ask quite a technical question, I'm afraid, so please bear with me, everybody, but can I just ask you what the compositions were and whether you used different compositions of copper or deliberately tried to work harden the drills, the copper drills, in order to increase their effectiveness?
The composition of the copper drills that I used, exactly. Okay, so that was the same composition as the copper used for the ring guiders, because we used only pure copper. So this was a 99% pure copper, I thought, and just you can buy that as industrial, but it was like copper you can collect yourself during the Neolithic, I think.
And did you apply any techniques like work hardening, for example, to try and change the effectiveness, the hardness of the drills before you use them?
No, unfortunately, we didn't have time to test that, but for the future, I noticed that will be very important, and with the flint drills too, because that was really amazing. This worked. It took a long time, but this worked.
Thank you very much. Yeah, I mean, I should point out to everybody that, you know, we've had a lot of experimental archaeology for metallurgy in terms of smelting and the primary process, but all this stuff to do with the secondary process is really new. So what you're doing is really groundbreaking and very interesting. So Agata, you have a question?
It was just written in the chat, and I'd like to thank you for your presentation. I was really excited to see it and to listen to it. My question is, did you record your experiments, and if the recordings are available somewhere?
I recorded some of the experiments, but we had some technical problems, so not all the experiments, and it was on 4 days, so we have just 2 days, I think, and so not the first steps, and it is for not unavailable, but I think maybe during my PhD to do something with that.
I can see that Christina Clark is trying to ask a question, so please turn on your video and go ahead.
Hello, Valentine. That was really fascinating. Thank you very much. I have experimented with making holes in copper using various techniques, and I'm happy to share some of my experience with you, maybe by email. But one thing I noticed in where you were trying to use a sort of a punch, that it looked to me that the sheet that you punch was not supported, and so it needs to sit on something like a piece of wood, so that the punch is supported underneath. From your picture, it looked like the sheet was sitting over a gap between 2 bricks, and that just won't work. It would just bend. So I thought I'd tell you about my experiences, if you like.
Okay, thank you very much. That's very important for me to hear things like that. And so we tested it on a piece of leather. So just a very, very fine piece of tissue, but it was not just like 1 centimeter, so not so much, I think. And it didn't work, but I will follow your advice. Thank you very much.
I'll send you some what I can.
Okay.
Thank you.
Thank you, Christina. And I can see that Cassia has a question.
A bit disappointed by the poor performance of your experiment with mold, and I was wondering if you actually have any mold findings. I was wondering if maybe it was the material of the mold you used that then affected the the final product. If you could say a few words about this.
Yes. So we had some big difficulties with this mold. I don't know what happened, what really happened, but for sure, I think that so there was the composition of the mold was so sandstone, but with a disgreaser. In French, it's vermiculite. Vermiculite. I don't know if you know that in English, but so some persons told me that because of this degreaser, it makes sort of a mix with copper, and so maybe yes. I really don't know what happened, but I want to test it again with different molds of different composition, and also with some agent for the unmolding, to prepare the unmolding, because as it is very pure copper, it is more difficult that bronze. So a lot of difficulties with pure copper. Thank you for your question.
But I mean, I think that all goes to show how important this kind of experimental work is. Is there any last questions for Valentine? I can't see any at the moment. If not, we will move on to Marianna's paper, which was about the find of the stake at Ayia Triada and Polina in context. So do we have anybody with any questions for Marianna? Okay, again, I will get the, oh no, hang on. I will turn over the floor to Kazimierz, please.
Thank you. Thank you very much for this very interesting and well done presentation. And there's an amazing number of metal finds. It's really amazing. Can you tell a few words what the royal villa really was, because of such an enormous metallurgical activity, and especially around Polythera, which we usually assume as ritual area or something like this?
Yes, yes, it's a very good question, because it's a real problem for us, because we have a lot of metals, and they are concentrated in two main areas of the villa. The first one is that I talk today about, and is around the Polythera, and but in special way is concentrated in the rooms that we think were warehouses and a kind of workshops, but in very linked in a special connection with the Polythera space. And the other one is the so-called Complesso della Mazza di Breccia, that is a separated place near the necropolis of the villa, and is a very different context, because in this place we have a lot of little rooms with a concentration of metals and molds. We have two molds, and for us is just a lot of molds, and we have to talk also about the ingots, the 19 ingots, and this is a very real problem. And in my project that is still in progress, and due to the COVID situation is in standby for this moment, I want to investigate the link between the ingots and all these metal finds, thanks to the collaboration with the Fort Institute in Heraklion. And we want to perform LIPS analysis to analyze the elemental composition of these metals. So I haven't actually a response, an answer, because it's very difficult to understand. But I think that there were one or two workshops areas, and I think that the use of the spaces in different way, maybe in different periods of the year, for example, is not so strange for the Minoan context. So I think that this connection is not so strange, and we have a lot of context, similar context during the Neopalatial period in Crete. So, but thank you for your question.
We have what looks like a comment in the chat from Anastasia Fagaki, who says bronze tools are found in the so-called Minoan halls in other cases as well. As the contextual re-examination of data proceeds, the ritual character should probably be revisited. So yeah, exactly what you were saying. And she also congratulates you on what was a really interesting paper.
Thank you.
Can I ask a question of you? And I don't know, perhaps at this point, Christina might put her head in her hands, but I wanted to know a little bit more about the stake itself, and whether the fact that it looks almost identical to the one that's shown in the Egyptian depiction is because of a functional reason, that's exactly how they have to be in order to work properly, or is it in fact showing technology transfer, direct technology transfer from Egypt?
No, I think it's very similar because the function is the same, and we have, unfortunately, we have just little examples in Aegean context, but this is a real this is a real fortune for us to have this comparison with the wall paintings in Rachmaninoff tombs, but I think it's just the same function. Yes, the typological function and the typological shape of these kind of tools.
Right, Christina, did you want to say something? You suddenly appeared on the video.
Yeah, I just wanted to say, Marianna, thank you for this really useful reevaluation of this tool, and I'd love to look at it in more detail. So so my research has been in reconstructing Minoan vessels and how they're made, and I was skeptical about that stake, basically because at the time there seemed to be so little evidence of its context that I could find when I did my research 10 years ago now. So I'm interested in reevaluating my evaluation of the stake now in the light of this new information. So thanks very much.
No, thank you. We know we have a lot of problems with our sources because the excavation was made in the first years of the last centuries. So I reconstruct the context through the notebooks. So it was for me a real opportunity to reconstruct this history, this find.
It's very valuable. Thank you.
Yes, indeed, and incredibly difficult to try and do that, so I do not envy you that task. Okay, so that looks like there's no more questions for you, so thank you very much, Marianna, and we'll move on to Polina. Does anybody have any questions for Polina about Middle Bronze Age pottery and looking at the firing technology through social practice? Yes.
I have one question. Okay, first of all, congratulations for your presentation, because I know you had to go through Middle Bronze Age pottery classification, which is maybe one of the most puzzling issues of the Aegean studies. And I found extremely interesting how you addressed the concept of visual aesthetics of the vessels, since we know that even in one single household, Middle Bronze Age vessels are very different. We can find painted pottery, burnished, coarse, and there is a much visual differentiations in the pottery assemblages of the Middle Bronze Age. What I wanted to ask is which one of the three firing methods that you presented would you include the pottery known as Argiveminian? That is, that pottery with homogeneous red core and black shiny surface, which from the outside it appears to be very homogeneous in the surface. It seems to be the product of a precise, of a specific chaîne opératoire. So how would you include this particular class of pottery, which is very common more in the southern Peloponnese more than in southern Greece more than northern Greece?
Thank you very much for your question and all your comments. I would relate this pottery, the Argiveminian, I will relate it to the third firing technique, according to the Colonna firing techniques. So to the firing treatment that involves initially mixed or oxidizing conditions, and then an intense states of reduction, a last stage of intense reduction. I didn't want to mention all these characterization and labels because they are really useful, of course, but as you mentioned, they are really confusing. I just wanted to focus on the visual effect of pottery, because this is what people actually see when they use a ceramic artifact. But yes, I would relate it to the third firing treatment.
And I really found very interesting the point you made about the appearance of the brightness of the surface treatment, because it is usually said that true grey minion is very well burnished, but in fact it is not as shiny as the products from southern Greece, these black minion, which are polished to a shiny appearance, while as you said, true grey minion usually looks quite, they say, soapy, quite dull. So this is very interesting. This is something that's very should be investigated more. Thank you.
Yes, I agree that it should be investigated more, and it is interesting, especially because it is combined with the difference in the surface color. So you have, on the one hand, in the central region and in Thessaly, you have mainly gray surfaces and gray-brown surfaces and this duller appearance. And in the southern Peloponnese, you have darker surfaces. You have these dark gray to black surfaces with the shiny texture. And it is interesting that both parameters also relate to the firing technique. Apart from the surface treatment, they also affected by the firing technique. For example, they can be affected by the degree of vitrification of the surface during the firing of the pot, and of course by the application of the iron-rich slip. But yes, this is something that I also think should be explored further in terms of aesthetics as well.
Thank you.
Okay, so nobody else has their hand up at the moment, so I'm going to sneak in with my question again. And it really struck me when you said about the fact that trying to fire a pot in completely reducing conditions is very much more difficult. In your opinion, is it something that can only be done by a specialist, if you see what I mean? Is it something that can't really be produced within a household production model?
Yes, this is a very good question. I think that it requires skill, but I can say that it can relate only to specialists. Because skill is something that may be related to other parameters. For example, the purpose for which the pots are produced, not only in order to be exchanged, but because they have another social significance. For example, they may have. I mentioned the hypothesis regarding the aged or antique look of these pots, and they may be socially significant because of that. But turning back to what you asked, I don't think that we can say that they are part of a specialized production because skill is required for their making.
Thank you. And I think, yeah, I can't see any other hands up at the moment, so I'll move on to questions for our final presenter, Flavia. So does anybody have any questions for her about the textile tools at Phaistos? Okay, I'll give a moment for people to write things in the chat if that's their plan. And whilst they're doing that, I will, oh, hang on, we have a volunteer.
I actually have one remark and a question from Agata, who unfortunately had to leave us for another meeting at the faculty. So her first remark was to always remember to publish spindle walls in the correct way. So with the wider part on the top, because that's how the spindle wall was actually fitted on the spindle, and that's how it was used. And as for the question from Agatha, she was wondering if you know if there is any evidence, if there was any evidence found around Phaistos, evidence of household textile production in the earlier period, so in the Palatial period, because you said that in the late Minoan tree there was this change of course, textile production, that it was now mainly done in the households. So her question was if there is any evidence from around Phaistos of earlier household production.
But I think
Sorry, Flavia, I can't quite hear you. Could you? Yeah, you're muted currently. Can you unmute yourself and? And are you still muted, apparently? Hang on, let me see if I can do something about it from here. Oh no, she's disappeared. All right, we'll give her a second and see whether she can come back on. This is clearly what happens when Agatha reinforces her point about every spindle well must always be shown the correct way up. She causes presenters to flee. We'll give her another minute or so and see if she's able to reconnect. Because I'm sure she would like to have the opportunity to respond to Agatha's question.
I can try and partly respond to Agatha's question. So there must have been a household production even in the Palatial period, just for the needs of the people of individual households. But Agatha was interested if there is any evidence from around Phaistos that maybe Flavia could tell a few words about.
Well, unfortunately, it doesn't look like she's going to be able to rejoin us at the moment. Whatever it was must have been catastrophic. I guess that given that, it's probably time to call lunch break, and hopefully she may be able to answer your question. Cassia may stick her in briefly during one of the later discussion sessions, if that's possible, if she ever manages to make it back. So everybody cry freedom and run for lunch, and please do return though, and please return at 3:35 Polish time. So please do figure that out for your own time zone. When we will look forward to presentations from our second session, which is on archaeological sciences. So thank you very much to our presenters. That was an absolutely fantastic opening session. And thank you very much to our audience, and hope to see you all later again today.